Hello everyone. Today we will learn about the ocean power generation. As the widest and most abundant energy treasure on Earth, the ocean contains a variety of energy forms and has an enormous potential for development. Firstly, let's understand the five main energy forms and their reserve of ocean energy. The first type is wave energy, which refers to the kinetic and potential energy of sea surface waves caused by wind. The reserves of global wave energy are enormous, especially in coastal and island areas, where wave energy resources are particularly abundant. The second type is tidal energy, which is the energy generated by the periodic fluctuation of seawater caused by gravitational force of the moon and the sun. The tidal energy has the characteristic of strong predictability. The third type is ocean current energy, which refers to the kinetic energy of directional flow formed by seawater under the influence of various factors such as wind and terrain. In areas such as deep sea and strait, the ocean current energy is particularly abundant and has stable flow velocity, which is conducive to power generation. The fourth type is temperature difference energy, which refers to the energy generated by the temperature difference between the surface and the deep layer of the ocean due to the solar radiation and the ocean circulation. Although the temperature difference energy is relatively dispersed, it still has certain development value in tropical and subtropical waters. The last type is salinity gradient energy, which refers to the osmotic pressure energy generated between the seawater and fresh water due to the salinity differences. Although this energy form is relatively small, the salinity gradient energy still has a certain development potential in places where the fresh water and the seawater intersect, such as estuary and lakes. Next, I will provide a detailed introduction to the main principles, process, and characteristics of these five types of ocean power generation. The first one is wave power generation. The wave power generation mainly utilizes the kinetic energy generated by the wave fluctuations to drive the power generation devices to generate electricity. These devices capture the motion of waves and convert them into the mechanical energy, which is then further converted into the electrical energy. The wave power generation has the characteristics of high energy density and wide distribution, but the efficiency of power generation is greatly affected by the size and the frequency of waves. The next one is tidal power generation. Its principle is similar to the hydropower station, which form reservoir by building the tidal dam. It uses the water level difference generated by the tidal fluctuations to drive the turbine to rotate, thereby driving the generator to generate electricity. The tidal power generation has the advantages of stable and predictable power generation process. At the same time, the tidal dam can also play a comprehensive role in flood control, irrigation, navigation, and other benefits. However, the construction cost of the tidal power generation is high and limited by geographical location. Let's take another look at the ocean current power generation. The ocean current power generation devices are usually installed on the seabed or the sea surface, using the most stable ocean current to drive turbine to rotate, thereby driving the generator to produce electricity. The ocean current power generation has the characteristics of the energy being stable and continuous, and the equipment has a long operating life. However, the installation and maintenance costs of the ocean current power generation equipment are relatively high. The temperature difference at energy generation uses the temperature difference between the surface and deep layers of the ocean, which is converted into the mechanical energy through a heat engine and then further converted into the electrical energy. The temperature difference energy generation has the advantages of not being affected by weather and having abundant resources, but its power generation efficiency is limited by the size of the temperature difference and the performance of the heat engine. The last one is the salinity gradient energy generation, which uses the salinity difference between the seawater and fresh water to generate the electricity through the semi-permeable and the principle of membrane and osmotic pressure, while the salinity gradient energy generation has pollution-free properties and the characteristics of low energy consumption. But currently, the technology is not yet mature and is still in the research and experimental stage. In terms of application, the ocean power generation can be widely used in islands, coastal cities, and other areas which often lack the traditional energy resources, but boast rich and sustainable ocean energy resources. In addition, the ocean power generation can complement other renewable energy resources such as wind and solar energy, forming a diversified energy supply system to improve the safety and reliability of energy supply. Of course, the development of the ocean power generation technology still faces some challenges and problems, such as the technological maturity, equipment reliability, environmental impacts, etc., which still need further research and improvement. Therefore, we need to promote the development and application of ocean power generation technology through the technological innovation and cooperation, and contribute to the sustainable development of humanity. Thank you.